Hello, dear student. Welcome on this video lecture. We have just finished vectors as a part of the mathematics for physics. Now, second important aspect of that mathematics for physics is calculus. So, we will be talking about this aspect of mathematics in such a detail so that it helps us in solving the questions of physics in future. So let's talk with this function and relation. So you'll get this kind of term, that's a function or relation. So what is a relation or a function? So whenever we write any equation, let's say this example we take and we start with that example. If we write y is equal to, let's say 2x plus 3. So that's called a function, or you can call it a relation. So what this function is, what is the relation over here that we need to understand. So here you can find, whenever this kind of expression is given to us, you will find there in that expression certain types of terms will be involved. So some terms will be constants. So if I write over here constants, so what are the constants in this? Can we identify those constants? Constants. So in this particular example, you'll find 2 is a constant, 3 is a constant, and here also 1 is multiplied if you want to see in detail. So that's 1 is also a constant. So these are the constants that are involved in this particular expression. Moreover, there are certain variables involved here. So what are the variables that you can see? There are 2 variables involved over here. One is y, another is x. So we call them as a variable. These numbers are variable, and these numbers are constant. Constants are those terms which do not change over the calculations. So they have a fixed value. Whereas the variables are those terms which may change depending on the situation. So they can take any value for that particular case. So they are called variable. Now constant, we know what the constant do. They remain constant, so they never bother us. How about we need to know about these variables? So 2 types of variable. This is y and this is x. Now you know that if we know the value of x, we can get the value of y. For instance, let's take an example. So in this example, let's say this is the example that we are carrying with, and within that example, and if we take x is equal to, let's say, 0. So if we take x equal to 0, you will be able to immediately identify what the y is. For that sake, what you need to do is place the value of x in this expression. As soon as you place the value of x in this expression, you're going to get this, like 2 into 0 plus 3, and which can be simplified to y is equal to 3. Now if we check this very simple exercise, then we can connect what these variables mean and what they are trying to say for us. In this expression, we substituted x equal to 0. That means we chose this x value, and once we choose this x value, y cannot be chosen. Y becomes fixed because of this expression. So what we say, this x is something that you choose. So these variables basically we categorize in 2 categories. One is dependent variable, another is independent variable. So here we are choosing x, so x can be chosen independently. So this is called independent variable. Independent variable. Whereas this y value depends on the value of x, so that's called dependent variable. So in any expression, we need to see what is independent variable, what is dependent variable. So whatever is independent, that's value we will be starting with, that can take any value as per its own, or you can choose any value. Based on that, another value or of the variable, dependent variable, value will become fixed. For instance, in the same example, if I have chosen x equal to, let's say, 1, then you'll find y will turn up as 2 into 1 plus 3, that we can write directly as a 5. So that means we can keep on choosing the values of x, we will be able to get the values of y, right? So this is called relation between x and y. So that's called a relation. This is also known as function. Sometimes we will write it in a different manner as well. We can write it as y is equal to this y is equal to fx. So we sometime like this, y is equal to fx. That means y is a function of x. So the same relation is also known as function. So if we relate with this for this example, so from here we can conclude that fx can also be written as 2x plus 3. So either we will be finding a relation like this or function like this. Fx is known f for function. So that's known read as a function of x, and that function of x is 2x plus 3, right? Or you can write it as a y is equal to 2x plus 3. Both are the same expression. That means we can write y is equal to fx. That means y is a relation of x or function of x. Making sense? Now when we say x equal to 0, that means we can also place over here, and we can say f equal to 0, that x equal to 0, so we place 0 over here. So it reads function's value at x equal to 0, and its value will be equal to 2 into 0 plus 3, that is basically equal to 3. Similarly, if somebody wants us to find f1, that means the intention is to find the value of that function when x is equal to 1, which we have already calculated. You will find it will come out to be 5. So this is another way of writing the same thing. This is another way of writing the same thing, and both are called functions or relation. Making sense? So this is how expressions are going to be written down. So we will be looking at the constants. Constants are very easy to handle. They remain the same all through the calculations. Variables, they can take different values. Two type of variables: dependent and independent. Independent are those whose values you can opt. Dependent are those who depends on the independent variable. Generally we will be finding one variable as an independent and one variable as a dependent. And the same expression can be written in this form. When we write f in bracket x, that's called function of x. So y is a function of x. Now here we are using x and y. We can use any of the terms. Let's say here there's a partition. I'm writing something over here. In physics we will be generally using another types of terms, like if somebody says v is equal to f of t. So what we are going to read it as, we will say v is function of time. So its meaning will be v is function of time. V is function of time. Function of t. T for time. In physics language, v is going to be the velocity, t is going to be the time. That means velocity dependent on time. That means if the time changes, velocity changes. So that time is independent variable and this velocity is dependent variable. So point is, we can replace this x by t and we can replace this y by v, and that replacement we can do in any expression. So wherever the need will come, we will be using different type of variables, right? So to understand how the relations between the variables goes, we are using x and y. Now in terms of x and y, the same expression can also be denoted or given or represented in terms of graph. So that's called graph or curve. So how we draw the graph or curve, how we can represent the same expression in this form of picture. So let's talk about. Now in graph, we know this is going to be y, vertical axis, this is a horizontal axis. If we are working in terms of x and y, so we will call it as a x-axis, we will call it as a y-axis. Now we can change the numbers, we can say the letters, we can say this is v-axis, this is t-axis, or any name we can give them. So we will be reading it as this is a horizontal axis, this is a vertical axis, and we can give the name of horizontal axis as the x-axis, vertical axis as a y-axis. We can give them any other names. In physics we will be writing other names, so we will be seeing which name is coming, but idea will remain the same. So the intersection point is called origin, we know that. Now let's say we need to represent this relation, the relation that we are talking about as an example, in this pictorial form. So how one can represent that relation? It's quite easy. It's this exercise that will lead to know the representation. So what we are going to do, we are going to choose the value of independent variable, then find the value of dependent variable, and then denoting those points. So let's say we choose x equal to 0, so y came out to be 3. So x equal to 0 and y 3, that's point going to be somewhere there. Then we will choose x equal to 1, y came out to be 5, so x equal to 1 will be somewhere there, and y equal to that's x equal to 1. So that was one point that we identified. Let me write downside, and this is x equal to 1. For x equal to 1, this came out to be y equal to 5. So that's going to be corresponding to 5. So how we denote it like this is 5 and this is 1. So the point is here. Makes sense? So we have drawn 2 points, but by using 2 points we cannot draw all the graphs. So what we need to do, we need to keep on this exercise, like let's take x equal to 2, then we'll get another point, then x equal to 3, then x equal to 4, or in fact we can take x equal to 1.5, 1.1, any number. That means on continuous fashion we can choose the value of x, and we will keep on getting the value of y. This was 3, this was 5, right? So what is going to be the case, that means we can identify, if you write all the points in this graphical manner, so we will be finding several points like this. I'm just denoting these points like this, and you can have 3-4 more points by calculation. It's not case that in all the cases you are going to get a straight line, but this is equation, so you are going to get this straight line. So if you keep on writing all the points, so you will getting this kind of so many points. Now if we join all these points, then you will find this kind of structure is going to be formed. So this continuous design, whatever we are going to get, that's called curve or graph. So we can say the same relation or function can also be represented by using graph or curve. So this line is called graph. So this is called y is equal to fx graph. Now graphical language is very, very important, and we need to learn what this graph is basically representing. So that's representing a relationship between x and y. What type of relationship is, if the graph is given to us, we can identify when x equal to 0, then y came out to be 3. When x equal to 1, then y came out to be 5. Similarly, we can choose different x over here. So if we choose a different x over here, we need to go some sort of this vertically up. Wherever it meets, we need to then move horizontally. So this value on the scale will be of y value, this value on the scale is going to be x value. So we can write this is x, this is y. This is how x and y are related. Making sense? So if the graph is given to us and x is given to us, we can find the y value. Same story is over here. If the function is given to us, x is given to us, we can find the y value. So both expressions serve the same purpose. Making sense? So there are certain type of relations which are very common for us. We are going to talk about those relations, and we will be learning their properties. But in overall, no many what expression is given to us. This is a very simple expression in which y has been given in terms of x, and x has a power 1, y has a power 1. We can make any complicated relation between x and y, that will be known as function, and there will be constants, there will be independent and dependent variables. By choosing independent variables, we will be able to find the dependent variables. We can also write in this fashion. We can always convert that expression, function or relation in terms of graph. So these things has to be understood. As I told you, in physics, what we are going to do, we are going to simply change the name x and y, and then we will be following the same relationship. If this is v versus t, so we will be saying that the graph is going to be like this. There's going to be vertical axis, horizontal axis, that will be t, that will be v. This graph, whatever the graph you have seen over here, that's known as y versus x. This is how we write y versus x graph. That means this axis is named first, then this axis. Using the same terminology, if the graph is plotted between v and t, so we will say this graph is going to be velocity versus time. So we will talk about what the velocity versus time is by an example later on, but here we are just learning what the nomenclature we follow. So this is v versus t graph or curve. This is x versus y graph or curve. Now let's move towards learning some important relations or functions which are very common in physics, and then we will be moving towards differentiation and integration, which are very important aspect that we have already decided. So the very first thing is called a straight line, and the relation or function of this straight line is given by this equation. So we are basically trying to relate x and y, and the simplest relation between x and y is going to be like this: y is equal to some mx plus c. Now here m and c, they are terms we have opted, and they are constants. So m and c are constants, just like 2, 3 we had example earlier. So they are constants. and x and y are variable. We can read this x is independent variable, this is dependent variable. So this is a general expression. Whenever we have this kind of expression, that means y raised to power 1, x raised to power 1, so that's also called linear relation. So this is called linear relation between x and y. Linear means they have single power. Linear relation or function. Whenever we have this linear relation or function, there are going to be two variables involved. One will be factor of x or coefficient of x, another will be a constant, right? So this is called equation of a straight line. So this is also called equation of a straight line. As you have seen in the previous example, a straight line came as a response, so that's a straight line equation. How that straight line being drawn? So this is a picture or graph that I have shown. This is y versus x graph. So that's a y versus x graph. Here what is M is indicating, what is C is indicating, that we need to learn, and we need to keep that in mind for future. So when we say that what is this M and what is this C, so let me directly explain you. Whenever we draw a line, any line in this xy plane, so you'll find that line can be extended in such a manner that it intersects x-axis somewhere. So if it intersects x-axis somewhere, so there are going to be two lines, one that line, another this x-axis. Whenever the two lines intersect, there forms an angle. So this angle is going to be formed between axis and the line. That's a straight line. And we can say this is y equal to fx. Or here this y is equal to, y can be written as y equal to mx plus c. So that's equation of y equal to mx plus c. Now this angle, when we see the intersection of this line with this x-axis, there are going to be two angles, of course. One is going to be this, another is going to be this. Now there's a particular way of measuring that angle. We will measure that angle from the positive side of the x-axis in the anti-clockwise sense. So this angle is of our importance, not this. So we will call this as a theta. Is it making sense? So theta angle is measured from the positive x-axis in anti-clockwise sense as a positive theta. So this theta we will be opting for. Now if we are opting this theta, so you'll find this M is basically equal to tan theta. We can see how this is coming, but this is something you need to keep in mind, and that's a very important aspect. So that's M is equal to tan theta. That means to find the value of M, what we need to know? We need to know that at what angle this line intersects the x-axis, and this is known as slope of the line. So M is known as slope of the line or a straight line. So whatever the factor of x is, when the factor of y becomes 1, then that's known as the slope of that straight line, and which is also equal to tan theta. Making sense? And theta is measured from the positive x-axis in anti-clockwise sense. So that becomes M value. So that's first constant we know. What about the second constant? Second constant is known as interception. Now you see, like in this expression, if we substitute in that expression x equal to 0, then you'll find y will turn up as a c. That means whenever x becomes 0, then y becomes c. That means x equal to 0 is this point, so this point is c point. So c is basically intersection of straight line with the y-axis. So if the intersection of a straight line is given to us with the y-axis, we can easily find what that point is, and that point is c. So c is known as intersection with the y-axis. Making sense? So we can conclude from here, c is y-axis intercept, y-axis intersection or intercept. Now so if the equation is given to us, either the graph is given to us, we can write the equation out of the graph, or the equation is given to us, we will be able to write the or draw the graph of that particular function or relation. So two important points for a straight line: one is a slope, extremely important; another the intercept on the y-axis. Now we can represent the slope in other ways as well. Let's say we have been given 2 points on the straight line. In this straight line you will get several infinitely many points are going to be there. Let's take one point over here, another point over here. Let's call this point as A point, this point is B point. Okay, so let me write A point here. This is A point first, this point is a B point second. Let's say A point has a coordinate x1 comma y1, B point has a coordinate x2 comma y2. So x1 y1 x2 y2, these are the coordinates, or that means these are the constant values, right? So what we can do, we can have some constructions. We can say this is going to be y1, this is going to be y2, this is going to be x2. So this is for B, so that's x2, and this is for A, so that's x1. Similarly, this is y2, this is y1. Now if I construct a triangle, I hope you can think that triangle. So let's say we extend this over here and join this point, so there's a small triangle is going to be formed. Now since this angle we have assumed to be theta, so can you think of this angle as also going to be theta? Because the horizontal line, same line is making the same angle, so that's also going to be theta. In that triangle, if we apply the tan theta version, so you'll find the tan theta in that triangle is going to be, tan theta is going to be this perpendicular divided by this base. Can you see what this perpendicular is going to be? Is it going to be y2 minus y1? So it becomes y2 minus y1. And what is this base is going to be? Can you see that base is going to be x2 minus x1? So base becomes x2 minus x1. So from here we got another important formula to find out the tan theta, and we know this tan theta is a slope. So that means we can find the slope of any straight line if we know simply 2 points. So if we know the 2 points, that means their coordinates, we can always write the slope by using y2 minus y1 divided by x2 minus x1. So this is also going to be used frequently by all of us in solving the calculations. This will also be used in mathematics, but we will be needing in physics also. So that's how we can measure the slope, that's how we can measure the intercept. Slope measurement can be two, so you got the measurement of slope by two methods. One, if the theta is known to us, we can find the slope. If the coordinates of the 2 points on the straight line is given to us, we can find the slope. Making sense? And to find the intercept, simply place x equal to 0, whatever the y comes, that's the intercept. Now we can also write the equation of a straight line in a different fashion if the 2 points are given to us. So let me say over here, if 2 points A and B are given to us, A and B are given, then equation of a straight line can be written like this. A straight line can be written like this: y minus y1 is equal to m, or you can write this value whatever we have already calculated in terms of y1 y2, which is y2 minus y1 divided by x2 minus x1 in bracket x minus x1. So that's also called equation of a straight line, and this we write in case we need to have we are given 2 points. So you can see if A point is given to us, which is written over here, B point is given to us, which is written over here. So x1 y1 x2 y2 are known to us, and x and y are going to be variables. x1 y1, they are going to be constants. So equation becomes y minus y1 is equal to x2 minus y2 minus y1 divided by x2 minus x1 in bracket x minus x1. So that becomes the equation of a straight line. So for a straight line we have talked about so many points. Measuring slope, measuring intercept, measuring slope in a different manner, writing the equation in this way, writing equation in this way. Okay, now we can also talk few more points about this. Since this m is equal to tan theta is a slope, so we can understand what this actually means. So next slide we are going to talk about what this slope actually represent and how we can think about the slope if the picture is known to us. So here we will be understanding slope in a better manner. So this equation, these are the straight lines. So I have given so many straight line equations, figures. So this is representing 1, let's say this is representing 2, this is representing 3, this is representing 4, this is representing 5. So here 5 straight lines have been drawn. In one graph generally we have one, so one will be shown to you. They can have a multiple as well. So I have shown there 5 straight line, and we will be talking about each and every one separately. So let's start with this one. So for one, this is basically, you can think of an example for illustration purpose. So for one, this is a first straight line, or let me write in this manner, straight line 1. So for this straight line 1, what we can see, can we think of what the slope it is going to make? So yes, for slope we need to say, we need to extend it till it intersect the x-axis. Now no matter how much part is shown to us, we can always extend it to any amount. So this straight line basically means that runs like this and goes to this. So we can take it up to any dimension. That means we need to keep on simply extending it, keeping it a straight line, and we can extend it up to any limit. So that means it goes to any length. So length is not a restriction. Now if we keep on extending in both sides, we will find it never intersect x-axis. Rather you will find they are parallel to each other. Since they are parallel to each other, so what the angle they are going to make? So you'll find the angle that they are going to make theta, that theta angle is going to be 0. Whenever the two parallel lines are, they always make angle 0. So theta is 0. Since theta is 0, so what the slope is going to be? Can you think of the slope? Slope is tan theta, so it's become tan 0. And what is tan 0? Tan 0 is a 0. That means it will have a 0 slope. So from here we can have a one concluding point. Whenever we have a straight line parallel to x-axis, that means horizontal straight line, its slope is 0. Very important point. So its slope is going to be 0, so that will have a 0 slope. Now let's talk about the straight line 2 as far as the slope is concerned. Well, I'm not talking about the intercept, because you can read intercept is this number will be given to us. So whatever this number is, that becomes c. So what we can say, intercept is positive. That's what we can say. Okay, let me write over here. For this, c is going to be positive. So that is about straight line 1. Now let's think and understand or try to answer this about straight line 2. So we need to see what the straight line 2 makes the angle with x-axis. So straight line 2, that's how this is intersection has been shown to us. So there is no need for in this extension, and we say that this angle is going to be the slope theta. So theta is going to be less than 90 degree. So for this, theta is going to be less than 90 degree. That's what we can say. Theta is less than 90 degree. Whenever theta is less than 90 degree, so tan theta will become a positive number. So this is going to be m is equal to tan theta. If theta is less than 90 degree, is always positive. So tan theta, which is less than 90, is going to be positive. So what we can claim for 2, the slope is positive. For 2, slope is positive. Making sense? And what about intercept? If you keep on extending it, it will be intercepting y-axis downside. Since intercepting y-axis downside, hence interception must be negative. Then you'll find, and the value of c is going to be negative in this particular case. So we are getting value of slope m and value of intercept for all these straight lines. If you have understood these two, then I'm sure you can answer about straight line 3. So what is straight line? What is about a straight line 3? Can we say if we produce it in this manner? So this is going to be angle. Making sense? So that's going to be theta 3 you can call, and that theta is again going to be less than 90. So theta is less than 90. Whenever theta comes out to be less than 90, we can claim the slope is going to be positive. Moreover, we can produce it to further to see where that cuts y-axis. It's again cutting y-axis downside. That means c is negative. Extending this to for this straight line 4. So for a straight line 4, what the theta you can think of? So again we need to extend this fourth straight line such a way so that we can see where it cuts x-axis. So that's x-axis or meet x-axis. Now here you will say, if we measure theta in anti-clockwise sense, so this is going to be theta. So that's our theta. you'll find theta is going to be more than this 180. Or you can say this is also theta, but this is a negative theta, so this is going to be minus theta. So that means it will have a minus theta or more large theta, you can say, and it's getting into third quadrant, right? So you will find that this theta is it's going to be getting in the this you can think of as crossing the third quadrant. This is for fourth quadrant, right? So, or you can say this is minus theta. So when we go in clockwise sense, we say minus theta. So you will find here the slope is going to be this negative. So we will say theta is, in this case you'll find theta is more than this 270 degree. If it is more than 270 degree, or we can call it theta is negative or theta is negative, both are going to be same thing. So we know when this angle becomes more than 270 degree or it's a negative, then tan theta comes out to be negative as per the rule. There is a rule called tan of minus theta is equal to minus tan theta. So that means slope is going to be negative. So from here we can conclude the slope is going to be negative. So slope is negative for fourth straight line. Making sense? And if you see this is intercepting at the negative y-axis, so we can claim C is also negative. Similarly, this straight line 5, which is also a different type. So for straight line 5, you can see what the angle is being formed. So this theta has to be identified. So you will say this is going to be perpendicular to x-axis, so theta is 90 degree. Theta is 90 degree. Whenever theta is 90 degree, you'll find m, which is tan 90 degree, is going to be undefined, or you can say infinite. So that's going to tending to infinite. So we will say the vertical axis or vertical line has infinite slope, horizontal axis has a zero slope. So this is going to be having infinite slope. And what is the intercept? It does not intercept, right? So C is not there, and this is going to be infinite slope. So by looking at the graph, we should be able to identify what kind of slope is going on. For instance, this, if it is horizontal line, slope is 0. If it is bent towards this right from the vertical direction, so slope is positive. This is also have a positive slope. But if it is bent towards the left from the vertical side, then it will have a slope negative. Why? The angle is going to be more than 90 degree, or you can say this is going to be like this bigger angle, or you can say you can measure from the downside, it's going to be negative. And when it is going to be vertical, then you say slope is infinite, tending to infinite. We place the symbol tending to infinite instead of saying m equal to infinite, because if for infinity is not defined, so equality is also not defined for that case, right? So this is how we can think of what the slope is. So once you see a straight line, you can see slope is positive or slope is negative. We are focusing on slopes too much because that's very, very important for us. We are going to link this later on. Let me give you an example how we are going to link it. Then you can think of just a quick example, because assuming that you know some aspects of physics. Let's say V versus T is given to us, or for further simplification, let's say distance versus time graph is given to us. Then we will find the slope. Later on you'll find slope is going to represent speed. So in this case you will learn slope is going to be representing speed. So by looking at the slope, we can talk about what the speed is going to be simply in this particular case. Or we can say if the straight line is given to us like this, so we can say what kind of slope is, so we can find the speed. If this graph is given to us and somebody asks find the speed, so simply we will find the theta and we say speed is going to be equal to tan theta. So I'm just trying to illustrate how important this is going to be for us in case of physics to measure the slope. So that's why we are measuring the slope, and we need to know how the slope is being measured. Moreover, we can have one comparative example over here. Let's say we talk about the second straight line and third straight line. Can you see both the straight lines are having a positive slope? Then can we compare which slope is bigger? M2 is bigger or M3 is bigger, or they are equal? So can we compare these two? Yes, we can compare. We can say this is going to be theta for 3, this is going to be theta for 2. Can you see which theta is going to be more? Now we start from this and we are moving in this way. If you move first, you are going to count this counter with this 3, then you will reach to 2. That means theta 3 is smaller, theta 2 is bigger. And we know in tan functions, if the theta is small, tan value is small. So if theta 3 is small, so tan 3 will be smaller. And tan 3 is smaller, so slope of 3 will be smaller. So slope of 3 will be smaller as compared to slope of 2. That means if we move from x direction towards y direction, then slope increases. And in case of vertical, it becomes infinite. So start from 0 slope, and if we keep on moving in this way, slope increases, and when it becomes vertical, slope becomes infinite when it goes this side, and then slope becomes negative. So 0 to infinite, then infinite to this negative, and again becoming 0 when it becomes horizontal back. Making sense? So this is interpretation of slope and how we can compare it. Let me give you one example on this, and then you need to answer that. Okay, so there are certain examples. Let me say questions for you. So you need to solve these questions based on the understanding that you have just gained in this particular video discussion. So let me briefly say what these questions are. First says, find the slope and y-axis intercept of the given straight line. So this colored straight line is given a straight line. These are xy coordinates. We need to find the slope value and intercept value. Second says, find the equation of a straight line if it passes through the 2 points. So A and B points are known to us. We need to find the equation. Also, we need to find the slope. And the third is, again, find the slope and intercept of this equation, which is given in this form, relation form. So the examples are dealing with the relation when given to you, and the graph when given to you, and when this kind of language is given to you. So they cover all type of questions needed for us. So solve them, give the answer in the comment section. And for the third, you cannot give the draw figure, so I'm going to take this as a question, or this is going to be the beginning of the next video. So I will be explaining how to give these answers. So you just solve and try to comment on the comment box what the correct answers are going to be. Well, so in this video, this is all, and in the next we will be talking about another relation which is important for us, or function which is important as us means physics, right? Okay. So thank you for watching. Have a great time.